After finishing the frame, only the electronics and control system remain for the shredder. Hi, welcome to Soul Engineering. I'm David. If you have been following this series, you will already know that Stepper has a compatible driver. The driver has a 220 VAC input that provides sufficient power to generate torque for the shredder. To set up the DIP switches on the driver, follow the table on the driver's side to set the current and micro-stepping. The torque is highly relative to the current. Therefore, I put the current to the largest one. Initially, I set micro-stepping to the default, expecting 200 steps a cycle for micro-stepping. Unfortunately, the default setting did not perform as expected, so I changed it to 400 steps a cycle. After setting up the driver, the next step is wiring. Connect 220 VAC and 4 wires to the stepper with corresponding phases. The driver's documents say it can be controlled by only using pulse and direction pins. I plan to use an Arduino Nano to generate pulses for the driver in the control unit. I experimented with ChatGPT to generate code and modify it for my purpose. Although ChatGPT is a helpful tool to generate code quickly, verifying the logic and details is essential. After the code is prepared, let me introduce the setup for the shredder. A button for the direction, a potentiometer to control the speed, and a display to show the direction. At first, I had planned to show the speed on the display as well, but that would delay the pulses, so I decided not to show the speed on the LCD. Another important for safety, I have included an emergency button. I designed a pair of electrical enclosures. A unique texture on the print is a characteristic of carbon fibered nylon. The first one is the emergency stop enclosure, a typical design for most enclosures. It has a panel on the top with a stop button and a large bottom enclosing the bottom's lower part. There are holes on the side for the wires to come out. The second enclosure is designed differently, with a diagonal cut, making it easy to install the display and access the inside. I created 4 small mountains on the corner to combine the two parts. This kind of design can only be achieved through 3D printing. Traditional manufacturing processes would be challenging to make this part. A test run first after the assembly. Turn on the power and wait for acceleration to complete. After the speed is stable, adjust it slightly with the potentiometer. It turns as expected. Let's put some parts in it. This is the shredder build. With the shredder, I will have an opportunity to re-extrude the flex into filament again. Like share this video if you enjoyed the building. Have a great day and see you next time.